We are going to look at the topic magnetism. This is IGCSE Physics 0625 Cambridge. So we're going to see how you're going to approach different questions in the event you are asked. So here we're told describe an experiment to show the magnetic field pattern of a magnetic field between the bar magnet. These are two bar magnets. And then we are going to describe how are the magnetic field patterns displayed, or how can you be able to come up with the magnetic field patterns. So the first thing you're going to do is to plot or place the plotting compasses at different positions. And then you are going to note the direction which the arrow is going to be pointing. So the direction of the arrow usually points to the direction of the field. This arrow here indicates the direction of the field. So once you have marked this point, you move the compass to a next position. Also, you mark the direction and you complete the pathway like that. So we're going to say place plotting compass on the cardboard near the magnet, mark the position of the compass needle north pole, and move the compass such that the south pole of the needle is at this particular marked point. So if you've marked this point and this is the north, then you move the compass needle next point. Also, you mark where the north is. You keep on following that pathway, and eventually once you are done with that, you are going to join all the lines that way for you to have the magnetic field pattern. The next part, we are supposed to explain and state the results about this. So a student has a bar magnet and a metal bar, and this metal bar has the ends X and Y. So we are supposed to state something about this metal XY. You realize when it's placed next to the north pole is attracted. When it's also placed at the south pole, it's attracted. So that means this metal bar is not a magnet, because one pole would be repelled if it was a magnet. But since it's being attracted, X is being attracted to both the north and to the south, then this is a magnetic material. So we can say metal X is made of a magnetic material. So that is why it's attracted by both the north pole and the south pole. Moving to the next part, and the next question says, on the diagram shows two bar magnets. We have a north pole and south pole. Then we are supposed to sketch the magnetic field. Remember, magnetic fields usually point from the north to the south. So you are to draw straight lines like this, and then you put an arrows which will indicate the direction of the magnetic fields. Number 4, you are told describe an experiment to identify these magnetic field patterns. You are given a question like this. We are told this is the magnet with a north and south pole. Then what experiment you can be able to use to identify this magnetic field pattern? In this case, we are going to use what we call ion filings. So we are going to place the magnet on a flat surface. Once you have placed it on a flat surface, then you cover that magnet with a thin sheet of paper. Then you are going to sprinkle ion filings evenly on the surface of that paper. Then you tap it gently. You just tap it gently. Then all the ion filings will be rearranged themselves. They will be arranged themselves in a pattern, and that pattern is going to represent the magnetic fields. Now, for you to determine the direction of the magnetic field, you are going to use a plotting compass, where the north pole of the compass will point the direction of the field. In the event you are asked to state the material that is used to create a permanent magnet, you are going to say steel. You can say, also use nickel metal. You can use cobalt metal, or you can use neodymium metal. Yeah, so that is as far as that particular question is concerned. Now let's move to question 5. You are supposed to describe a method of demagnetization. How can you be able to demagnetize a magnet? How can you be able to make a magnet lose its magnetism? That is what we mean by demagnetization. So we're going to say you are going to heat that magnet to high temperatures. Maybe it becomes red hot, then you allow it to cool down. So meaning that the dipoles will arrange themselves. Or you can be able to repeatedly hit that particular magnet with a hammer, and that in that way it's going to lose its magnetism. Looking at question number 6, explain why iron is suitable for a suitable material for the core of an electromagnet. Remember, an electromagnet is a magnet which is magnetic because of the presence of electric current. So this means that iron is a magnetic material, so it can be easily magnetized it's a magnetic material, so it can be magnetized. Then iron is a soft magnetic material, meaning it can be easily magnetized, and at the same time it can be able to easily lose its magnetism. So for that reason, iron can be able to form or create a temporary magnet when current is flowing, because when you want to create an electromagnet, you would like it to be a magnet when the current is flowing down, then immediately you can be able to it loses its magnetism, immediately the current is cut off or switched off. So that is the reason as to why it's suitable used. But steel metal is suitable for a permanent magnet, because once it's magnetized, it maintain or retain the magnetism for a long period of time. Then we have question 7, where we are supposed to describe how we can be able to demagnetize a magnet by the use of what? By the use of alternating current. Remember, you magnetize a magnet by using direct current. But if you want to demagnetize or to destroy a magnet, you need to use alternating current, whereby you are going to ensure that this particular current is flowing. Alternating current should be flowing as you are withdrawing the magnet from the solenoid. And that's why I say place the magnet inside a solenoid, pass a large alternating current through the solenoid, and then now slowly withdraw the magnet while the current is flowing, so that that particular magnet is going is going to be completely demagnetized. But if you make a mistake and you switch off the current, then withdraw, then there are chances that the magnet is going to retain its magnetism. Yeah, so here we have a bell. So you may be asked to explain how a bell works, an electric bell. You may be asked, how does this electric bell works? You can see here we have a soft iron core, and then we have a coil here where current is going to pass. As current, when the switch is closed, current is going to flow through the coil, and this U shape will become a magnet. Then it will attract this part, or this armature. Then once the armature is attracted, you can see there is a hammer that is going to hit the bell, and it's going to do what? To produce sound. And once this is pulled down, you can see there is a contact here. Then that contact will be open, which means current will stop flowing, and this immediately stop being a magnet, and the process keep on repeating itself. So in order to explain this, I'll give a precise answer for this particular question for you to earn 5 marks. You are going to say, when the switch is closed, current flows through the coil, the coil becomes an electromagnet. The coil becomes an electromagnet. Yeah, the coil becomes an electromagnet. The electromagnet attracts the soft iron armature. This electromagnet will attract this soft iron armature, and this causes the hammer to move and hit the bell. So as the armature moves, this breaks the circuit, at the contact at this particular point. It breaks the circuit at this particular point, and the current stop flowing. Then this one loses the magnetism. Then the armature breaks the circuit at the contact screw. Yeah, this breaks the current, so the electromagnet loses the magnetism. Then we have the spring. When it loses the magnetism, this spring is going to pull it back. Then it will complete the circuit again. Current flow, this will attract it down, and the process keep on repeating itself. So in the event you are asked a question, that's exactly what you're going and how you're going to approach that particular question in your IGCSE exam. Yeah, looking further into this, we are having a spring here, and we have unmagnetized ion lock. So you can see now, if you close the switch, we're seeing how electricity can be able to be used to lock the door. You can see now we're having a spring here, and we have the unmagnetized iron bolt. Immediately current flow through here, this part becomes a magnet, so it's going to attract the bolt, and the bolt will be attracted, and this is going to lock. Immediately switched off, the spring is going to pull this backwards, and exactly that's what we are going to say at that given point. So let's see how you're going to answer that question, because we are told that the ball is initially in the position shown on the diagram. Describe and explain what happens when the switch is closed. When the switch is closed, what's going to happen? This will be magnetic, so it will attract it's going to attract that particular bolt to lock. So we're going to say, when the switch is closed, the current flows in the solenoid, and the solenoid become an electromagnet, and this magnetizes the iron bolt, inducing a north pole on it, and like poles are facing each other, and then the bolt is attracted into the solenoid and moves into the lock frame slot. Yeah, so meaning that immediately this become a magnet, this is going to be pulled and is going to move into this slot, and that means going to lock the door. Yeah, so you can see immediately it pulls, going to lock the door. Then if it's locked like this, when the switch is open, current stop flowing, then it means that this particular coil stop being a magnet, then the spring is going to pull it back. That's the principle, how it works. So the switch is reopened, the current in the solenoid stops flowing, the solenoid loses magnetism, so it's no longer attracts the bolt, and that means the spring now contracts. This spring here is going to contract and is going to pull the bolt back, and that's going to let the door to open. Looking at question number 10, we are supposed to state, in question number 10, we are supposed to state and suggest the metal that can be used to make a bar magnet or a permanent magnet. We can use steel, because steel is a hard magnetic material. Hard magnetic materials are those materials which can be cannot be easily magnetized. Hard magnetic materials are those materials which cannot be easily magnetized, but once magnetized, they retain the magnetism for a long period of time. And we would like the magnetism of a permanent magnet to retain the magnets for a longer period of time. So basically that is why it's used. So examples of hard magnetic materials which can be used to make permanent magnets include steel, nickel, cobalt, and we also have neodymium. Then we have part B. We are told the diagram shows a bar magnet being inserted into the coil. We have a bar magnet here which is being inserted into the coil. We are supposed to explain why is this galvanometer going to deflect? Why is it going to move? Remember, when this particular magnet is pushed into the coil, it has what we call magnetic fields. It has what we call what? Magnetic fields. And these particular magnetic fields are going to cut across. Let me just show you what I'm talking about. So this is what I'm saying. At this particular point, we have this coil, and this coil is not having current. So here we are having a magnet. Show you. Let me remove this a little bit. So let me have. So we have the electromagnetic fields here. The magnetic fields are pointing like that. Those are pointing away from the north. So when this particular magnet is pulled in and out, these magnetic fields are going to cut through the coil. And when magnetic fields cut through the coil, we are going to have a change in the magnetic flux, which is going to result to inducing an EMF in the coil. Once an EMF is induced in the coil, it will result to the flow of current in that coil, which is going to be displayed by the deflection of that particular galvanometer. We are supposed to explain what determines the direction of the reading on the galvanometer, and then we are going to say that that deflection is going to depend on the direction in which this particular magnet is being moved to. Moving to number 11, you can see here we are having a soft, in this case we are having an iron bar, and this iron bar is not having poles. So if you bring an iron bar close to a magnet, it will be attracted. So meaning if this is a north pole, a south pole will be induced in this side of the iron bar so that it's attracted. But if you are going to swap the positions of this, again a south pole is going to be induced at this particular point. So you realize that there is going to be an attractive force because we are having opposite poles. The diagram shows a bar magnet and 4 floating compasses, and then we are supposed to place positions, and here the floating compass will face that direction, here it will face that direction. So the fields are going, the direction of this arrow on the floating compass always point the direction of the field. So the field will be going into the south pole, fields will be getting out of the north pole. You need to remember that compass, the arrow always point the direction of the field. And the last question that we are having here, we are told that a student wants to demagnetize a permanent magnet, and she should suggest this procedure. Number 1, place the magnet in the long coil, switch on a large amount of alternating current, switch off the current, remove the bar from the coil. The question was, state and explain whether these steps will always be able to demagnetize a magnet. Now, one of the mistakes this student has mentioned is switching off the current and then remove the coil, because we said from the previous question that you need to switch on that large amount of current and then withdraw the coil. If current is flowing around the coil, then withdraw the magnet from the coil while current is flowing, and that will now ensure that all the magnetism is lost. But otherwise, if you switch off the current and withdraw, it means you are going to there are chances that the material may retain the magnetism.